Hello, my name is Magjaziva Jeffrey, MH22019. My friend and I will present about our group project Dynamic with title Single Slider Crank Mechanism. So, our project is aimed to understand and solve the dynamic system, especially looking at how things move and interact. We'll focus on the principle of kinematic and kinetic, studying how rigid bodies behave under the motion and force. The goal is to explore the challenges and complexities that come in dynamic system. So this is the picture of the single slider crank mechanism. As you can see, it has 5 point A, B, C, and D and E. Objective of our group project is to suggest the length of the bar AB and BC, sketch the graph illustrating velocity at point C and acceleration at point C, and determine the force exerted at B by using the method of equation motion, and determine the angular velocity at rod BC by using the principle of work and energy as the block C move from position E to D. So the methodology for our group project is using relative motion analysis to find the length of at AB and BC. Next is we use equation of motion analysis to uh, determine the velocity at point C and acceleration, and we also use the principle of work and energy analysis to find the force exerted at point FB, and lastly we use the equation of energy analysis to find the angular velocity at point BC.
For the first question is, if it is required that block C to move back and forth in between position D and E as rod AB rotates, suggest the lengths for bars AB and BC. For the solution is VC equal to VB plus VB respect to C. VC equal to omega AB RAB plus negative omega BC RB respect to IC. Negative VC I hat equal to RAB omega AB cos theta J hat minus RAB omega AB sin theta I hat plus 1.4 omega BC plus RAB omega BC cos theta J hat plus 0.2 BC plus RAB omega BC sin theta I hat. For the assumption, I use omega AB equal to 0.2 radian per second. For VC is equal to 4, theta equal to 45 degree, omega BC equals to 0.27. For the I hat part, negative VC equal to 0.2 omega BC plus RAB omega BC sin theta. RAB equal to negative 10.7585 meter, and then the RAB equals to 10.7585 meter. For the J, for the next is the negative VC I hat equal to RAB omega AB cos theta J hat minus 10.7585 times 0.2 sin 45 I hat plus 0.27 k hat RC respect to B, 0.27 RC respect to B equals to negative 2.4785 I hack minus 1.5215 J hack. RC respect to B equals to negative 9.1796 I hack minus 5.6351 J hack. So RCB equals to square root 9.1796 square plus 5.6351 square. The RCB is 10.7712 meter.
So my name is Excelsius Vista, MA 22058, and I will explain for the question. Sketch a graph illustrating the velocity and acceleration of box C as a function of the angular position of rod AB. So first, we choose the velocity C is equal to VB plus VB with respect to C. Next, negative VC I hack is equal to omega AB K hack in bracket RAB cos beta I hack plus RAB sin theta J hack minus omega BC K hack in bracket minus 1.4 plus VAB cos theta I hack plus 0.2 plus RAB sin theta J hack. Then we will simplify the equation for the negative VC, and then we will calculate the I hack. So negative VC I hack is equal to 0.2 omega BC plus RAB omega BC sin theta, and then finally VC is equal to 0.2 BC plus 10 omega BC sin 45. So and then after the get, we got the simplified all this the equation, and then we just insert the value, the angular velocity BC, and then we will get automatically get the velocity C value, and then we put all of the value, which is 0.27 until the 1.04, and then we'll get like on the this right side, this is the graph for the angular velocity BC. Okay, and for the next we will calculate the acceleration of block C. So first, acceleration C is equal to acceleration B plus acceleration C with respect to B. And then next, acceleration A, I hack is equal to alpha AB K hack R AB cos theta plus R AB sin theta J hack minus W AB square in bracket R AB cos I hack, I'm sorry, cos theta I hack plus R AB sin theta J hack plus in bracket negative alpha BC minus 1.4 plus RAB cos theta I hack plus 0.2 plus RAB sin theta J hack, and minus omega BC square minus 1.4 plus RAB cos theta I hack plus 0.2 plus RAB sin theta J hack. And then we will just simplify all of this equation, and then we will also got the alpha AO is equal to 3. So then we will simplify the equation, and we will calculate for the equation of I hack. So acceleration C I hack is equal to negative RAB alpha AB sin theta minus RABW, oh I'm sorry, omega AB squared cos I hack plus 0.2 alpha BC plus RAB alpha BC sin theta minus 0.2 omega BC squared minus RAB omega BC sin theta. And then for the J hack, 0 is equal to RAB omega AB cos theta plus 1.4 omega BC plus RAB omega BC cos theta. Okay, then we will calculate the AC as you can see in this slide, and then finally the equation is AC is equal to negative 23.6457 plus 0.2 alpha BC plus 10.7585 alpha BC sine 45, and then we will just insert all of the value in this table, and then we will see the graph on the next slide. This is the graph for angular acceleration BC and acceleration C as we got from the calculation for the acceleration of block C.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Muhammad Sentri. My metric number is MA22067. So today I will explain about question 3. So if we look at this question, the question asks to suggest the step-by-step solution to determine the force exerted at B by using method of equation of motion. So as we know, first thing first, we must draw free body diagram. So in this case, we have three parts. First is road AB, second is road BC, and last is block C. So for road AB, we have weight at the center of this road. Second is for road BC is we also have the weight of this road in the center of it, and also FB at point B and FC at point C. Last is for block C, we have weight only in the center of this block. So this is how the kinetic diagrams looks like. We have FT, FN, and also MAGT. Okay, by using the equation of motion of road AB and block C, we can write equation and solve for the unknowns TA and TB in terms of given quantities like mass AB, mass BC, gravity, omega AB, mass C, and also I for road BC. The mass for MBC can be calculated using the known lengths of AB and BC and the desired between position D and E. So this is equation of motion that we use. First is summation Fn equal to MAGN. Second is summation Ft equal to MAGT, and last is summation MO equal to IO alpha. So for summation moment at point O, we can separate this equation like this. Next is for AB, we can find the value by using summation Fy equal to 0. For BC like this, and also block C like this. Once we find the values of TA, TB, and FC, substitute them back into the equation for road AB to solve for FB. That's all from me. Thank you.
So for next question, which is question 4, we need to suggest the necessary solution step to determine the angular for road BC by using the principle of work and energy as the block C move from position E to position D. So this is the free body diagram for the single crank slider mechanism. At the top is the position from D, and down at the bottom is the position for point E. This is my calculation. First, we need to find the T1, which is equal to T translation plus T rotation. So T translation equal to 1 over 2 mass, multiply it with velocity at point G square, plus it with T rotation, which is 1 over 2, multiply it with mass moment inertia at point G and multiply it with angular velocity at point BC square. So to find to find V1, in this case we don't have springs, so 1 over 2 ks square is equal to 0 because the rigid body doesn't have uh, spring. So the only work made is by the mass, which is equal to y, the y multiply it with weight at G. So that's all from me. Thank you.